With the recent collaboration between Microsoft and OpenAI, we can now create powerful applications by combining Azure functions with AI models. In this video, you'll learn how to build and deploy a Chatbot API using Azure AI Foundry step by step. First, we'll create an Azure Function App and provision an Azure OpenAI resource. Then, we'll deploy a model in the AI Foundry portal. Next, we'll build and refactor the function in Visual Studio. And finally, we'll publish it to Azure and test it in Postman. Let's create an Azure function. First, click on the Azure function icon in the portal and choose the Flex Consumption plan. This plan is flexible and cost-effective. Select your resource group or create a new one. Name the app. It must be unique. Leave Secure Unique Default Hostname on. Choose a region close to your users. I'm using East US. Set runtime stack to .NET and version to .NET 8 LTS isolated worker model. Set instance size to 2048 megabytes for a good balance of performance and cost. Optionally enable zone redundancy for higher reliability. I'll keep it off for now. When everything looks right, click Next. We'll leave the storage as it is and click Next. In the Azure OpenAI tab, enable Azure OpenAI. In the details, you can see that our region is automatically set to East US. A new Azure OpenAI resource will be provisioned along with it. We'll ignore the vector storage option for now and keep the default. Next, we'll leave networking, monitoring, and deployment options set to their defaults. That keeps the setup simple, and you can always customize these later if needed. On the Authentication tab, I've set Managed Identity for the host storage, deployment storage, and application insights. For Azure OpenAI, we'll leave it as secret since that's the only option available. In the section below, you can see that Azure will provision and assign a managed identity for this function app. This provides secure access without storing keys, and it can always be changed later if needed. We'll now review and create our app. On the final screen, Azure shows a summary of all the choices we made. If everything looks correct, just click Create. Azure will then provision the function app along with all the connected resources. After the deployment finishes, we'll see a confirmation screen. From here, we can jump directly to the resource. On the Function App resource page, we'll click the resource group to see all the associated resources. Here we can find the Azure OpenAI resource and open it. Inside the Azure OpenAI resource, we'll find the button Explore Azure AI Foundry portal. Clicking this will take us directly to the Foundry portal where we can create and manage model deployments. In the Foundry portal, we'll click on Create a Deployment and choose the model we want to use with our function app. For this demo, I'll select GPT 4.1 Mini as our deployed model, which is excellent at handling complex problems. After confirming, just set your deployment name and type, then hit Deploy to kick things off. And while Azure is setting that up, go ahead and smash the like button and subscribe so you don't miss future tutorials. Once the deployment is complete, head to the Deployments tab in the left pane to view your newly deployed model. Now we'll move on to creating the Azure Functions project inside Visual Studio 2022 LTS. I'll start by giving the project a name and selecting the location where it will be saved. Next, I'll specify the function worker, and for this demo, I'm choosing the .NET 8 isolated worker model. The rest of the settings will remain at their defaults, and finally, I'll set the authorization level to anonymous so it's easier to test. Once I click Create, Visual Studio generates a function app for me with the boilerplate code already in place. I'll go ahead and rename the default function 1 to chat function so it better reflects the purpose of this demo. Before we start implementing the function, we'll need to install a few dependencies. For that, we'll head over to the AI Foundry portal and open our deployed model. By selecting C#, we can view sample code for calling Azure OpenAI, along with a list of required NuGet packages that need to be installed. I'll now switch back to my project and install the required packages. To do this, right-click on the solution, choose Manage NuGet Packages, and then browse for and install the ones you need. Okay, now let's dive into the code. I've copied this snippet from the sample code in the AI Foundry portal, where we've set the endpoint and deployment name, and the API key is still a placeholder for now. I'll show you how to copy the actual key later. Using these values, we initialize the Azure OpenAI client and call the getChatClient method with our deployment name to get the client instance. Next, we configure the chat completion options. The temperature controls how creative or deterministic the responses are, while top P adjusts the randomness by limiting the pool of possible tokens. Frequency penalty helps reduce repeated words or phrases, and presence penalty encourages the model to bring in new topics instead of sticking to what's already been said. I've created a list of chat messages to send to the model. The first one is a system message, which sets the behavior of the assistant. In this case, telling it to act as a helpful assistant. The second is a user message where we're asking, "I am going to Paris, what should I see?" We then pass these messages, along with the request options, into the complete chat method of the chat client. This call sends the messages to Azure OpenAI and retrieves the model's response. Finally, I return the model's response as an OK object result. This is where we copy the API key and paste it into the placeholder I showed you earlier. For now, this works, but keep in mind that hard-coding API keys directly in the code isn't safe. In a moment, I'll refactor the code and show you a more secure approach to handling secrets. We'll now publish what we've built so far by right-clicking on the solution and selecting Publish. In the wizard, choose Azure, then select Azure Function App. And if Visual Studio is connected to Azure, you'll see the Function App we provisioned earlier. Finally, select it to create the publishing profile and click Publish to deploy the code to the cloud. Once the publish process is complete, you'll see the function deployed in the Azure portal. Click on its name, then select Get Function URL and copy it. We'll use Postman to call this endpoint, and as you can see, we're now getting the desired output. Now let's refactor our code to make it more professional. Inside the function app settings, we'll search for environment variables, and here you'll notice that Azure has already configured the Azure OpenAI key and endpoint for us when the app was provisioned. Instead of hard-coding these values in our code, we'll read them directly from the configuration. And I'll show you exactly how to do that. In this refactored version, I've added iConfiguration to the constructor so we can securely read our endpoint and API key from the environment variables instead of hard-coding them into the function. This makes the code more professional, secure, and easier to maintain. I've also created an incoming message class with role and content properties. This allows us to receive messages directly from the request body rather than embedding them inside the code. Since our function is triggered with an HTTP POST request, the method type here will always be set to POST. We've declared a string variable called body, where we'll read the incoming request body using a stream reader. If the body turns out to be empty, the function returns a bad request response, reminding the caller that we expect a JSON array of messages. Then we create a list of incoming message objects and use JSON serializer.deserialize method to parse the request body into that list. With property name case insensitive equals true, the deserialization works, even if the JSON property names use different casing. The deserialization step is wrapped inside a try-catch block to handle errors gracefully. If the request body cannot be parsed as valid JSON, the catch block logs the error and returns a bad request response, letting the caller know the JSON format is invalid. After that, we retrieve our endpoint and API keys securely from the configuration, and we also set the deployment name for the model we want to use. This way, everything is properly wired without hard-coding sensitive information into the code. We create the Azure OpenAI client using the endpoint and API key, then call getChatClient with our deployment name to get the chat client. Finally, we set up the chat completion options with parameters like temperature, top P, frequency penalty, and presence penalty, just as we did earlier. In the final section, we loop through all the incoming messages and map each one based on its role. If the role is system, we add it as a system chat message. If it's assistant, we add it as an assistant chat message. And if it's user or anything else, we treat it as a user chat message. Once all the messages are added, we call complete chat async with the messages and request options to get a response from Azure OpenAI. Finally, we log that the request was processed and return the model's output as an OK result. Now that we've refactored the code, we'll republish the function app to Azure and test it again using Postman. In this example, you can see I'm sending a POST request to our function endpoint. The request body contains a JSON array with two messages, a system message that tells the model to act as a helpful assistant, and a user message asking, "I'm going to Osaka, Japan. What should I see?" When we send the request, the function processes it. calls Azure OpenAI and returns the model's response, confirming everything is working as expected. And that's it. We've successfully built and deployed a Chatbot API using Azure Functions and Azure AI Foundry. I'd love to hear your thoughts, so drop a comment below and let me know what you think.